Now, let's move on. We want to give you a summary of materials, what they are, and sort of give you some map, some mind map that gives you a summary at a glance of what materials are.
Right, here we go.
Now, up there we've got matter and materials, and we can see that we can classify this into two groups. Some of them are pure substances and some are impure substances, which we call mixtures. And from the pure substances, we have what we call elements, and we will soon be introducing that to you, giving you examples of that. We also have compounds.
And those are not mixtures of elements, are they?
No, they are not. And from elements, we move down to what we have just been talking about. We have been talking about non-metals and metals. Those two groups of materials constitutes what we call elements. And these are actually happening or occurring naturally. The non-metals, we have natural gases as examples of that, but some of them obviously can be in a solid form. That will be substances like carbon and others.
Ceramics, all our pottery. Yes, carbon, a very important non-metal indeed.
Yes, and under metals, we can give you examples like copper. We are quick to talk about copper because we know we're using it a lot in terms of electrical conductivity.
Yeah, when it's not being stolen.
Yeah. Yeah, and we can have gold, tin, and a rest of others.
Many, many.
Yeah. So that is a quick summary. And when we come to the side of the mixtures, let's just talk quickly about mixtures. We see that when we have mixtures, we do have what we call homogeneous mixtures.
Means this of the same kind.
Homo would mean same, yes. So we've got a mixture of the same kind of material. It could be in a liquid form, all of them, or in solid form, all of them.
So it is a mixture of two liquids which do mix.
Yes.
Whereas two liquids like oil and water
that cannot mix are still a mixture that is not homogeneous.
Okay.
In the sense that they are not mixing into one form.
Okay.
Heterogeneous. Hetero means not in the same phase or not in the same form. So we would talk about, say, a mixture of water and sand. You will still have sand, distinct from the water molecules. Unlike when you have got water or seawater, for example, it's salty. We know there's sodium, there's lots of different salts dissolved in water. And that will be a homogeneous mixture because you can't just look at it and say, I can take out the salt and take out the water.
Okay.
So that's what is meant by homogeneous and heterogeneous mixtures. We will, of course, maybe say a little bit more later on about them.
Well, one of the things we will say, and it's a very important thing, is how to separate mixtures.
Yes.
And the interesting thing about separating mixtures is we go right back to the properties of the materials to see what is distinct about it that allows us to separate things out. And we focus. So that's another reason that you need to know the properties of material so that you can work out how to separate things, and only then will you get your pure substances.
Exactly. I think this picture here gives us a nice summary on which we can end the lesson. And we will build up from this in the next lesson.
Good.
Thank you so much for watching.
Bye.
Summary. In this lesson you learned about mixtures, semi-metals or metalloids, that the formal definition of a pure substance is one that consists of only one type of particle which cannot be separated into components by physical methods. That pure substances can be elements or compounds.